Hello, my name is Robert, and I've been a public school math teacher for many years. And this is going to be a free Algebra 1 math class for those who wish to refresh their algebra skills. So, we're going to begin with some pre algebra topics just to make sure that everybody has the background information they need to be able to be successful. These will all be short lessons where I'll be going over the different topics that you'll encounter in a typical Algebra 1 class. So we first begin with number sets. Now, number sets are just groups of numbers, and we have a bunch of different types. So we have natural numbers, which are whole positive numbers, and they include 0, 1, 2, 3, and so on. So those are our natural numbers. Then we have our integers, and our integers are represented by the letter Z because that's how you say integer. The German word for integer starts with the Z. Now, every natural number is also an integer. Integers include positive and negative whole numbers and zero. So every natural number is an integer, and examples would include -5, -4, -3, 0, 1, 2, 3. So every positive and negative whole number and the number zero. Next are the rational numbers, and the set of rational numbers is represented by the letter Q. Now, you may see the word ratio in rational numbers. So, those are any numbers that can be represented as a fraction. If it's written as a decimal, then that means that it will be a decimal that will either terminate or it it repeats at the end of the decimal number. So it'll keep going like 0.666, and that goes on forever, and that represents 2/3 as a decimal. And if you think about it, it's obvious why natural numbers and integers are rational numbers as well. And that's because I can represent, for example, the number 5. 5 is a natural number. Well, I can represent that as a fraction. I can just make it 5 over 1. So any whole number can be represented that way. Or the number 0. 0 over any denominator is equal to 0. So I can represent 0 as a fraction. So that means it is also a rational number. So you may start to see this pattern. The smallest, any member of the smallest set of numbers, any numbers that are natural numbers, are also members of these other larger sets of numbers. So every natural number is also an integer. Every natural number is also a rational number. Every natural number is also a real number. Every integer is a member of the rational numbers. And so rational numbers, again, are any number that can be represented as an integer divided by a positive natural number. And examples are -2/3, 1/2, 0, or the whole numbers as well, because they can be represented as a fraction. So 5 over 1 is another example. Then we have the real numbers. Now, real numbers include, again, every one of the smaller sets of numbers. So all rational numbers are members of the real number set. Every integer is a member of the real numbers. Every natural number is a member of the set of real numbers. And this includes then numbers that are not only ones that can be represented as a fraction, but it also represents numbers that cannot be represented as a fraction, like pi. We know that pi goes on forever. So pi cannot be represented as a fraction. It does not ever repeat, and it so it can't be represented as as a ratio or as a fraction. Another example of a real number that is not a rational number is e, which is 2.718. And again, it goes on forever and it never repeats. So, a good way to think about this and to look at this is if we look at a a diagram, and we can see a diagram like this. It shows that the natural numbers are on the inside, and then just the next square outside of the natural numbers is the set of integers. And then outside of that is the set of rational numbers. And then finally, we have another set in a box that, or a square that surrounds the inner squares, and that is the square of real numbers. And so that makes it easier when we see this to understand that the members of the smaller sets are all members of the larger sets as well. So, some examples for some questions that I would want you to practice on, just to make sure that you understand this, are: what is pi? Is pi a real number, a rational number, an integer, or a natural number? So what is pi? And then next, what is the -3? So write down every single number set that these numbers belong to. So first you have pi. So what sets of numbers is pi a member of? Two, the number -3. Which number sets is -3 a member of? Three, what about the letter e, the variable e? Now, what members of which set is e a member of? Then number four, the improper fraction 7/2. What is that a member of? Which sets of natural numbers is 7/2 a member of? And finally, the fifth problem would be 4. What set of numbers is 4 a member of? So that gives you some practice for these questions, which just help you to be able to identify what set a number belongs to. Well, I hope that this was helpful, and I look forward to seeing you again next time. Thank you. Have a good day.